Assalamualaikum warahmatullahi wabarakatuh and good day, student. As mentioned in my email, there will be no online class session for today, but I have instructed you to do tutorial question number 10. So I hope you have done the tutorial question and you are able to obtain the correct final answer. But for those who have not obtained the correct answer, worry not. Let's review the solution together as in the following video. Assalamualaikum warahmatullahi wabarakatuh and good day, student. In this video, we will discuss tutorial question number 10 under topic 3, laws of motion. Question number 10 here, a 3 kilogram block starts from rest at the top of a 30 degrees incline and slides a distance of 2 meters down the incline in 1.5 seconds. Find A, the magnitude of the acceleration of the block, B, the coefficient of kinetic friction between the block and the plane, C, the friction force acting on the block, and D, the speed of the block after it has slid 2 meters. To solve question number 10A, we can use kinematics equation because all of the information required to calculate acceleration are being provided inside of the statement in the question. Here we're going to be using x final is equal to x initial plus with vxi t and then plus with 1 over 2a t square. X final will be the final position at the final time, and here it is going to be 2 meters. So we're just going to put in 2 equal to x initial. At the initial time, it is at the top, it is still not moving, and it is going to be equal to 0 plus with vxi. Because it starts from rest, it is also going to be equal to 0 multiply with the total time for this motion to happen 2 meters away from its original position is 1.5 seconds. So plus with 1 over 2, acceleration is the unknown that we need to obtain, and then the time is going to be 1.5 square. In this case, acceleration, if you calculate correctly, it is going to be equal to 1.78 meter per second square. So this is the acceleration experienced by this 3 kilogram block. Okay, so now we are ready to solve the next question, which is 10b, finding the coefficient of kinetic friction between the block and the plane. To help us with drawing the free body diagram and afterward to solve question 10b, finding the coefficient of kinetic friction, we're going to be using this figure, which is taken from tutorial question number 5. Right, so this configuration or this figure for tutorial question number 5 is rather similar to tutorial question number 10 because we have this slope here, or this inclined plane. We also have a block. Alright, so with that, we're going to put in information that we have according to the question. Angle is going to be 30 degrees, and remember that this is going to be a rough surface because we need to know what is going to be its coefficient of kinetic friction. Alright, so to draw the free body diagram, we will take a look at this list of forces. For the first one, there are no applied or external forces that is actually being exerted on this object. And afterward, we have to take a look at the second force, weight or gravitational force. Because this block has a 3 kilogram mass, it will also experience weight. So the weight is directly downward direction, so W is equal to mg. So moving on afterward, the third force that we have to consider is going to be tension in the string. Looking at the diagram or considering the question, there is no mention of string cable, wire, rope, and so on. Because of that, there is going to be no tension for our question. Moving on to the fourth force here, it is going to be normal. Definitely we're going to have normal because the 3 kilogram block is rested on this inclined plane. Because it is on a plane or on a surface, it will also experience this force, which is going to be normal force. So the normal force is going to be perpendicular or 90 degrees to the plane of the surface, right? So this is a line, this dashed line is parallel with this inclined plane, so it is going to be 90 degrees with the surface. Moving on afterward, we also have to consider friction force, and then here we have kinetic friction force as stated in the question. Because this block is going down the incline, our direction for friction force is going to be opposite of the motion, and then with that the friction is going to be upward or up the incline. So this is going to be the friction force, specifically kinetic friction force. Okay, so moving on, number 6, or the last force here to be considered, is going to be spring or elastic force. So there's none of this spring or elastic force because there's no spring and there's no elasticity mentioned in the question. So we are actually almost done with our free body diagram. So another thing that we have to draw is going to be the axis. Okay, so normal is going to be having this continuation line on the lower part of the axis, which is going to be, we can see that that is the negative region of the y-axis. So for our reference, okay, this is going to be our x and y axis. So the x and y axis is going to be along the incline or tilted with this angle of 30 degrees. Okay, so that is x and that is y axis. And then another thing that we also have to consider, because we have the acceleration, I'm also going to be drawing the acceleration. So the acceleration is going to be definitely along the incline. So this is the acceleration. So the acceleration, as you can see from the diagram here, is going to be in a single axis, x. So this is x, and then this is our acceleration that we have obtained earlier. Earlier we have obtained the acceleration to be 1.78 meter per second square. Okay, with that, I'm going to be transferring this diagram, okay, to solve question number 10b, where we need to apply Newton's law of motion. Okay, so now we're going to be creating equation based from our free body diagram using Newton's law of motion. So firstly, we will start with the x component. Okay, so for the x component, looking at the diagram here, we have acceleration along the x component. Alright, so this is our acceleration, and then this is the x-axis, and then we also have two forces acting on the x-axis. The first one, as you can see here directly, it is going to be the friction force. Okay, so the friction force reduces the acceleration, but we also have to consider another force, which is going to be the weight. So the weight is also acting on the x component, because the weight here will have both x as well as the y component of its vector. So I will be drawing The first vector for our weight here, the component is for the y-axis, wy, and then we can also draw another vector for the x component, which is going to be wx. So because w here is directly downward, because it is parallel, okay, with our vertical side of the triangle, we can use the information about this corner of angle 30 degrees. So with that, this is going to be 60 degrees, whereas this is going to be 90. We can transfer the 60 degrees angle, so it is going to be the angle between wx as well as w. So between w and wy, it is going to be 30 degrees. With the knowledge about trigonometry, we can write down wx is equal to w or mg multiply with cos 60 degrees. Meanwhile, for wy, it is going to be w multiply with sine 60 degrees. Okay, this is angle between wx and w. Alright, so as you can see from our Fibonacci diagram, so far there's no problem with normal as well as the friction force, because they are exactly on x as well as on y axis. However, because w is tilted with this angle, it will have both component wx as well as wy, because it is moving slightly to the left as well as moving slightly downward. Okay, so for x component here, we're going to use the second law of motion. Total force is equal to ma, because there is this acceleration for the x component, and then we have to find the summation or the total force acting on the x component. We're going to write down wx, and then we also have fk, okay, which is going to be the kinetic friction force. Here, because we are adding all the forces, we're going to put this plus sign. However, remember that force in this case is vector quantity, meaning that they will have direction. Because force has direction, we also need to write down the signs that is going to be showing its direction. For the weight, wx, it is going to be negative, because as you can see, it is going against the direction for positive x direction. So we can see that this is positive x, and then wx is moving relatively to the left. Afterward, fk, which is going to be the friction force, is going to be positive, because it is in the same direction as the positive x direction. And afterward, it is going to be equal to, in this case, it is going to be negative acceleration. The acceleration is negative because it is moving to the left, so it is going to be negative ma. Afterward, we have to put in its equation to find wx. As mentioned here, it is w or mg cos 60 degrees. Alright, so mg cos 60 degrees, and then plus with friction force, okay, kinetic friction force. For friction force here, we have the equation to be fk is equal to mu k multiply with n, which is the normal. So we can write down it is going to be mu k and then multiply with n. And then remember, normal force, it doesn't have exact equation, right? So we need to derive. So we will take a look at n later. Okay, so it is going to be equal to negative ma. Okay, so moving on. For n here, this is normal. It is along the positive y-axis, and then to find normal, okay, we have to use the y component. So for the y component, because we cannot proceed here since we don't have the formula to calculate n. So for the y component, we're going to be using the first law of motion, which is total force is equal to 0. Reason being is actually acceleration is only on the x-axis. So total force for the y-axis is 0. And then in this case, we have two forces acting on the y-axis, which is going to be the normal. Right, so normal is positive because it is upward direction or the same direction as the y direction, positive y direction, and then plus with, in this case it is going to be added with negative wy is equal to 0. So in the end, as you can see here, n is equal to wy. Okay, wy is positive because here initially it is negative, but because I bring it to the other side of the formula, it will be positive. And then we know that wy is also equal to mg sine 60 degrees. So now we can substitute it back into our original derivation here. So it is going to be negative mg cos 60 degrees and then plus with mu k mg sine 60 degrees, and then it is going to be equal to negative ma. So now we can eliminate m. Reason being is because m appears on both sides of the formula, so we can eliminate m. Okay, eliminate m, and then this is going to be the final formula. So now actually we can substitute the value. Here it is going to be negative 9.81 cos 60 degrees and then plus with mu k multiply with 9.81 sine 60 degrees. It is equal to negative a. Remember that a has been obtained previously in question 10a, which is 1.78. Alright, so we can solve this. Okay, so here it is going to be negative 4.905 and then plus with it is going to be 8.496 and then multiply with mu k, and then it is equal to negative 1.78. So mu k is going to be equal to negative 1.78 plus with 4.905 over 8.496. So mu k is equal to right, so the answer that I have obtained is 0.368, and then that is going to be the correct final answer. So for the coefficient of friction, in this case it is dimensionless, it doesn't have unit. Okay, so this is going to be the answer for B. Alright, so because of that, we can now proceed to solve question 10C. So for question number 10C, the question asks for the friction force acting on the block. Right, so for C, the question asks for the friction force. Fk is equal to mu k multiply with n. Alright, so mu k has been obtained, which is 0.368, and then we have to multiply with the normal. The normal is also equal to wy, and then wy is equal to mg, if you can recall, mg sine 60 degrees. So we're going to substitute the value, which is going to be 0.368 multiply with the mass, which is going to be 3 kilogram, and then multiply with g, gravitational acceleration, which is 9.81, multiply with sine 60 degrees. Alright, so the kinetic friction force is going to be 9.38 Newton. So this is going to be the answer for question 10C. And last but not least, the question asks you to calculate the speed of the block after it has slid 2 meter, which is finding the final speed. Okay, so here we need to find what will be the value of Vf. So far we know what is going to be the total length, which is 2 meter. We also have the, in this case, the acceleration as well as the time. So there's plenty of kinematics formula that you can use. For this one, I will be using the simplest one, which is Vf is equal to Vi, and then plus with At. Alright, so Vf is the one that we need to obtain. V initial is equal to 0. And then the acceleration is going to be 1.78 based from question number 10A. And the time that it took is going to be 1.5 seconds. Okay, so the answer that I obtained is 2.67 meter per second. And looking at the final answer provided for question number 10D, that is indeed the correct final answer.